and how you can prevent lag on MySQL. How many people are familiar with MySQL? Okay, great. Right, so I'm going to do a quick intro, then I'm going to talk about the origin of the idea, the technical challenges that I have faced building this little script. Then we'll go through the logic flow of the script, and I'll do a brief demo and the possible improvement of the script. So I'm a senior MySQL DBA. I've been a MySQL DBA for about 10 years, and I've been a MySQL DBA about 10 years. I have some experience in database modeling, database architecture. I work for a few large companies such as Leveneur, Rubicon Project, TrueCar, ZipRecruiter, and now I work for WAG. So WAG is hiring. So if you're interested, you go to wagwalking.com, and then you scroll down all the way to the bottom of the page in the career, and they're hiring people because we're growing. So I just started working there about a week ago, and I was hired to scale their MySQL stack. Now, the origin of the idea. When I was working at Rubicon Project, we had masters and slaves, and oftentimes we had issues. The slaves will stop, so we had to figure out what went wrong. So I started, using MySQL Binlog to look at the binlog. And sometimes, you need to find out exactly where the errors has occurred. So I started using that tool. So it was very much for replication debugging, going into the binlogs and looking at potential issues and where to restart the slave, etc. Then I realized, well, the binlogs, people are familiar with the binlogs, right? So the binlogs are used to replicate from a main server, master, into a slave. And the binlogs contain all the transactions, all the insert, update, delete, that occurs on the table gets stored into the binlog. There's different formats, right? Statements, or row, or mixed. The most common one used is row format because it's much efficient and it allows it's more precise. There's no issues with timetable, etc. And when you do large updates, it's much faster, and it doesn't have as much lag. It prevents lag on the slaves. So I started doing those binlog analysis, and I started, I looked at it and said, well, maybe I can summarize that data and find out, how many insert, how many update and delete that server is, producing and going through each day, right? That allowed me to detect surge, right? Sometimes for no reason the slave will start lagging. There was no specific queries running, but there would be a spike, a short one, on the slave, and then it was not easy to find out. Using the binlogs, I was able to analyze it and see that there were a big update that would go through. Because when you run a row, you don't see anything on the slave. When you run statement, you see the statement running on the slave, but when you're in the row format, you don't see anything. So that's a little more difficult. So that's why by analyzing the binlog, you really know what's going on. So it will really help me find, the replication lag and pinpoint to the table and focus on which table to diminish the number of writes on, a specific time during the day. Because, when your traffic goes up and you have bash script running and you're inserting a lot of data by joining other tables, right? You can easily insert thousands of rows into your database. And then it helped scan for planning. Plan for scalability. We'll go through this toward the end. I'll explain to you how being able to look at the binlogs can help you scale MySQL. So I had questions sometimes from developers or for my supervisors, asking me, okay, how many transactions do we have on MySQL? You can use performance schema. This will give you some metrics, But across time, it's a little more difficult because performance schema is limited. You cannot store as much history. You can record that, but it's a little cumbersome. Performance schema also adds some load on MySQL, where the Binlogs it gets replicated. It's totally has little impact on the server. How many inserts on one table between this time and this time, right? This is a little more difficult because now we are looking at a range of time precise, right? I want to know between 2 o'clock and 3 o'clock on that table how many inserts we've been doing. Do we delete data on that table? No need to look at the code. You don't need to go look into your PHP, Java, or whatever script, right, and grab it to see if there's any delete on that table. Just looking at the bin log, you'll know. Which table is the busiest? Which table is going to grow the fastest across time? Because if you have a lot of inserts on the table, that table is going to grow. And it's going to eat up a lot of disk space, memory, right? So you're going to have issues scaling. And the trend, right? Trends are very important. When you want to scale, when you're building an application, you want to make sure your database stay the same, that it grows slowly. You don't have spikes or big changes that affects your application. For example, at WAG, when I started working, they had lags. So that means when you have lag, you cannot really use it to run your select statement because there's a delay between the master and the slave. Slaves are meant to scale your reads. You move all your select statement to the readers. So by looking at the bin logs, you can detect this. You can see quickly what's happening. So this is an example of once you start analyzing the bin logs and you store it into a table, you can start graphing, and you can see quickly, where you need to focus, right? So on the left side, I blanked it because they were a real table, but on the left side, you would have the list of table, right? And here we have TPS, transaction per second. They are really the number of rows that have been inserted per second, right? So this is where you need to focus, right? Quickly, right? You have the blue is the delete, the orange is the insert, and the red is the update. That table, right, is mostly updates. This one, look at this. 3/4 of it is update, and 1/4 is, update, inserts, et cetera, et cetera. So this, at a glance, you can say, I'm going to focus on this block because these are probably all the transactions in the table that are generating a lot of lag, right? Then you can look, I think this is across time, right? 0 to 24 hours during the day. How does our transaction behave, right? Where are our peaks and what's happening during that time? Same thing, right? Updates, inserts, around 9 to 10, right? You see a scale here and then goes down, right? And then during the night, nothing. So this again, it allows you to monitor it, and if you, by doing trending, you can quickly see, changes across time. Now, something I wanted to point out is I use a technique called row weight, right? So I grab the row size by joining the data size, right, divided by the table rows, and I get the row size, then the index size. I add them, and I multiply the transaction per second. It gives me the row weight transaction, right? Because some tables are small, have few columns, and some tables have large columns. If you're doing a lot of updates on a small table, like a few rows, that's fine. It's going to be fast because you're not shipping to the slave, a lot of data. But if your table is wide, if your table has text fields, varchar, etc., and you're doing a lot of update inserts, this has to ship to the slave. This use network, memory, processing, all these counts. And that's where, the slaves start, lagging. Another view, right, schema. Which schema is doing the most transaction? Now, if you have only one schema, well, that won't help you much, right? But if you are hosting websites and you have hundreds of, of database, and you want to see which schema is consuming the most bandwidth, right, or CPU, this will help, right? And if you add a new database, right, you see here nothing happens, and then slowly it starts going up, then you can monitor also those new schemas. How are they going to scale? So across time, you can monitor this, and you can plan already the growth. This one also same thing, right? But using the weight. So it's a little different. Now we are half, right, of inserts and half of the updates because I applied the raw weight, to the table. So as I said earlier, the binlogs allow you to, to detect surge, right? By using trend, the script analyzes the binlogs, store the binlogs, it summarizes it into a table, summary table. Then you can plug any tool, right? You could plug Periscope, any graphing tool to it. You can download your data, plug it into Tableau, Excel, right? Then you can start graphing and see, how your database is behaving. And you can detect across time changes. Prod release, right? You do a prod release, you push some code into production, and suddenly your CPU goes up, right? Everything is normal, but there's more CPU usage or more network usage. By looking at the binlogs, you can see that if there's any additional inserts, update, or delete that have been added that are impacting, the database. Am I doing a lot of updates on the table? Did I put a script into production that, is not right, that is updating too many rows? Batch jobs, same thing. You deploy a batch job on production, you can affect, production. You can affect master and your slaves because you have a script that runs that deletes too many rows. Large alter. So when you alter a large table, there's some techniques where you create a temporary table with the proper schema, and you migrate the data in the new table. This will show up inside the, the binlogs because you're going to be inserting a lot of data. So this is also another type of graph you can do, right? You can compare today, this is July, how, we're doing, and here we can see that we have more transactions per hour than 1 week ago. And you can compare by table level, something you cannot do in performance schema or other tools, right? And here it's per table. You can see that table H, we have a big problem, huge, right? In 1 week, we went from here to here. Something happened. So what you can do is you can query the binlog and see which statement, caused this, and then you can fix it. Because everything is stored, right? All the insert and all the update against each table are stored and summarized, and then you can query this. So the row replication format is the most common one. When you use GTID, it allows you to do multi-threaded. So you can increase the speed of replication, right? And when you use logical clock, it's a little better. Aura is getting a lot of attention on the market. They just released 5.7. I'm not sure if they support GTID, but Aura is not, there's some also issues with it. You cannot scale, you cannot forward it everything. You still need to optimize it. There's some limitation. So by using the binlog, you can look at the wrong queries or transactions that you're running against Aura. So large update, delete, and master, right, will generate lag on the slave. So when you have hundreds of transactions per second, right, which one it is? Which one is generating all those issues. And then when you have many rows that are affected, it becomes even more difficult, because when you use row replication, if you run one SQL statement, one update that updates 1,000 rows, you would have 1,000 rows in the binlog, right? So that's why you really, by using row binlog, you really see what's going on at the table level, how many rows are being shipped. Instead of statements, if you run one statement, if you were using statement replication, running one statement on the master will run one statement on the slave. With row, it's really different. And on the slave, you can also turn on the binlogs. And if you do that, you can tune it. You can see, okay, maybe there's some table I don't want to replicate to the slave. Like, for example, a log table, right? I just need to have it on master. So you'll save, some bandwidth. This will help you remove the lag. I mean, log table should not be in MySQL, period. Should move that to S3, right? But, maybe for some particular reason, you need to have a certain table that is large. You don't need to have it on the slave. You can, filter it. Or you can also scale by partitioning certain slaves. You can say those slaves, they're only going to replicate those tables. So planning scalability, right? So we saw that we have a precise DML monitoring tool. We can see everything, what's going on, on the database. We can monitor the surge that can occur during the day. And scaling is not always about adding more machine. You can scale by reducing. And that's something we did when I was working at ZipRecruiter. We had to scale 10x. That was the goal. But if you want to scale 10x, you can reduce by 5x, right? You have, let's say, 1 million transactions per day. If you divide that by 5, right, you have room. You immediately create room for growth, right? And you don't need to buy new hardware. So the logic flow of the script, right? First is to get the binlogs to download it, to get the start and end date of the binlog, so that you know which time frame this binlog corresponds to, because they get generated, right? So usually you set a size, every, for example, 100 megs, a new binlog is going to be created. Then you parse it. Then you store the parsed DML. And then you keep track of the binlog being processed so that you can rerun it, right, every day, certain hours. So it's a pretty simple, right, nothing complicated. Download binlogs, get the start, parse it, store, last binlog, yes or no, go back, and it rotates. So we're going to just look at the script very quickly to see, how this is done. Now, the technical challenge was the grabbing the binlog start and end date. This was not easy. I had to spend a little time to figure it out. But by doing some grabbing, that was possible. Parsing the binlog, I found some script online, and then I made it better. Long host name. If you use Amazon, AWS, or RDS, the endpoint is usually very long. That's not very elegant, right? You need to parse it. If you use an IP address, something you need to parse that because you're going to have dots. So it's not, there's some parsing that needs to occur. So I'm going to look at the code very quickly to give you an overview. Okay. All right, so it's a very simple script, right? I didn't do, it's in batch, right? So the first thing I do, I create a table that's going to store the counts, right? It's here if it doesn't exist. I clean up the binlogs because sometimes the binlog hasn't closed. And when that happens, the range is negative. So I have to get rid of it and then reprocess it, right? And then I have a loop, right? I do a show binary logs. That's a command for MySQL to show all the binary logs on the master. I get the list, and I do a count. Has the binlog been processed? Right, this is the binlog process, where the binlogs equal binlog and the hostname equal hostname. And then I start the processing. So you can download a binlog from a remote server using MySQL binlog read from remote server. So you do that, it's going to connect, grab the binlog, download it, and here it downloads it, locally. Because it's a raw format, you have to use raw, and then you store it into a directory. Then I process the start date, right, by doing some grepping, the binlog end date, and then this is where the magic happens. Right. This is the entire, script that basically parse. You see here update, insert, delete, replace, create, alter, drop. So you can add on, commands if you want to. It's not limited. Then I load data into, a count table. I truncate it first, right, and load it, and then I store into a summary table. And then after I update the process, right, I clean my file. So what you can do also is, as soon as you download your binlog, you can copy it to S3 for backup, right? This way you have a copy of it. I mean, there's so many, you can do a lot with this, right? Otherwise the binlog is loading, et cetera, et cetera. Right? So it's a very simple, and I mean, I didn't spend too much time developing it. It's very basic, but it works. I schedule it, it downloads, and it processes the binlog. So let's look at it on demo then. Right. So here, binlog, I pass the IP address, right? So it checks, okay, process. This binlog has already been processed, right? So it goes to the next one, boom, and it finds the other one, and now it's processing, right? It's getting the start date of the binlog, the end date, then it's going to parse it, and then store it into the table. So those binlogs are stored into, first you have the binlog process table. So it tells you the start date and end date of the binlog and the binlog name, right? So that's also useful if you say, oh, and think of it 6 months from now, right? You have backed up your own binlogs, and you say, okay, I want to find some data 6 months ago. You can look at the binlogs and see, what was happening and what we were inserting at that time, right? It's you can refer to the binlog that you store into S3 and bring it back, reprocess it. So it's very useful. And this is where you summarize, right, all your data. So the host name, I remove the dot for the IP address, the binlog start date and date, total transaction, so total rows that have been processed, the table name, right, so schema table, and what type of query. And on the right is the binlog time range. So it's basically the start date minus the end date. And this is useful because you can quickly see that the shorter the time range, the more transaction you had, right? Because you're storing more transaction in a very short amount of time. Your binlog is limited to 100 megs. So when you insert a lot of data, it's going to get filled very quickly. And that's what happened here. I mean, look at this. Here, I had a huge insert on this table. And that occurred between this date and this date, etc. So using that, you can write some very simple query, right? And you can start, summarizing it. Here by date, by hour, these are the total transactions that my database is going through, right? Or, same thing, date, hour, what type of query, the actual query, and the transaction. So a little more detailed. When you store this, you can slice it, any way you want. becomes very useful. And the last one, a little different, you summarize by hour, you see the total transaction, and then number of rows per second. Right. Now the possible improvements. So hardening the script, like I was saying, it's a very simple one. It could be better developed to do more. For example, parsing the binlog on top of the hour, that could be useful because right now the binlogs, they don't always rotate, on the hour. They rotate anytime they're full, when they reach the maximum size. So, when you start because it's a range, the range doesn't always stop on the hour. So you could have it, from one day to another. So it becomes a little more, over time, it's okay because it's a trend, right? But having it on top of the hour will guarantee that you have transaction, and even better by minute. If you could process those binlogs by minute, then you increase the granularity and you have more detail for the transaction. And a graphical representation like anemometer. So anemometer is a tool that was built by Box, I think, for the slow query logs. Something similar could be done where you actually graph your binlogs. And when you zoom in, it will query the summary table and give you more detail. Is there any questions? Yes?
Thank you very much, first off. The histogram by table was a very interesting idea. Is there any reason why you didn't use like an existing tool like PT Query Digest instead of?
Well, PT Query Digest is meant usually for slow queries. Mm-hmm. So this is the binlogs. Right. Well, okay. And slow query usually is for selects, right? I know it converts the insert and update into select statements. Mm-hmm. The slow query log is mostly for, for the slow queries. Since there's a binlog tool available, I decided to use that. You can also use a start date and end date. Mm-hmm. That allow you to, look at a certain time frame within your binlog, right? Because this gives you a pretty good idea, but sometimes you really need to go within 2 seconds because you have thousands of transactions going per second, and sometimes you need to analyze between 2 seconds, right? So the binlog tool will do that. It will allow you to really focus on that particular moment and see what happened there.
Thank you.
Sure. Yes?
Is your current implementation open source?
I haven't done that yet, but that's something I would like to do, yes. I'm not too familiar with Git and how to make it open source, but yeah, definitely. So if there are people interested that want to work with me, better the code, make it open source, great. Totally open. Yes?
Are you going to share those resources online somewhere?
Yeah, I can. Definitely. Yeah, it's. I think I didn't title the presentation, well. I should have, probably do it for, MySQL lag or scalability, because that tool really helped. I mean, at ZipRecruiter, when I was working there, it really helped scale Aurora, because Aurora, when you have massive inserts, right, and updates, it affects, the readers, the replicas. So being able to identify those culprits very quickly is very useful. And there's also a limit in bandwidth on Aurora. So, it's all network related. And replicating, it's costly. It's not free. So being, sometimes you come on board and you have table using text field or varchar and you're inserting a lot of data, JSON, right? These will impact your SQL. Yes?
Do you have an example of like a major performance issue that you were able to track down with this sort of analysis?
Yeah, some spikes. That's as ZipRecruiter, we had spikes that would occur at a certain time, And we could not pin it down at, just using some monitoring tool. We'd see the spike, right? And we didn't know what it was. So by using the Binlogs, we were able to focus, right, on that particular moment and going into it saying, oh, that's this table during that time. Now you have the table, now you have the time, you can go and grab your cron, then you find the bash job, that it's doing it. Or you can look at the log, your web log, that's most of the time that's what you need, right? Which table, the more information you give to the developer, the easier they can find information, right? Which table it is, between that time, tell me what happened. And you can also correlate with logstash, right? If you're storing your binlogs in logstash. You can also, because you have the table name, you can join with information schema and get the size of the table, data, index, right? You have the reads also. So you can start, same thing, building a more precise, monitoring tool. And the good thing about it is it's really, performance schema is great, but, it consumes memory, and it also affects, it does use resources, because it has to store, in those tables. Where here it's totally, transparent. Nothing happens. Any other questions? So if you want to reach me, right, that's my email address. Feel free to email me if you have any questions. I'm going to look into putting the code, online, making it open source, because it saved my life multiple times. I mean, at work, many times I had to use it, and it's very quick. Once you have those queries built, you just run it, boom, you have the answer immediately. All right, and thank you.